Algebra 1, section 10.6, the quadratic formula. We'll start right in with quadratic formula. If ax squared plus bx plus c equals 0 and a is not equal to 0, then this is the quadratic formula here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you may have been exposed to that before, and you may have heard someone recite that before, but I do want to just take a moment and break it down just a little bit. First and foremost, to get the numbers that you plug into the quadratic formula, you need this to be in standard form equal to 0. Okay? If we don't have standard form equal to 0, we're going to need to get it into that form so that we can extract, if you will, the a, the b, and the c. And they say if a is not equal to 0, because if a were equal to 0, then you don't have a quadratic term, and you don't really have a quadratic problem to deal with. You'd be dealing with a linear equation to solve. Okay, so that they throw that in there. And basically what the quadratic formula is, and I've done this for classes before. I could do it. It takes a whole sheet of paper, but you can solve this equation for x, as in get x by itself, and it involves completing the square, and that's why 10.5 comes before 10.6. That's why completing the square comes before the quadratic formula. And I've shown classes before. I don't think they really appreciated it, but this is how you get the quadratic formula. You get x by itself, and this is in its simplest form, right? There's nothing else that could be done to make it simpler. If we could, we would have made it simpler. In a normal year, we would have made you memorize the quadratic formula. And a lot of times what happens is after you do the homework assignment, you end up just memorizing it anyway. One more thing before we move into some examples is common mistakes that I see students doing the quadratic formula wrong. One is to have a times symbol here instead of plus or minus. Remember that with these quadratics, you're going to get two answers, likely. Okay, not always, but we should be expecting two answers. So, and that's where that's going to come from. You're going to, whatever b turns out to be, negative b gets added to the square root of b squared minus 4ac, and then it also negative b subtracts from it the square root of b squared minus 4ac, and then both of those get divided by 2a. So that's going to yield two different answers. We should be expecting two answers. What else? The fraction bar. The fraction bar goes all the way across here. So everything that's in here is the numerator, negative b plus or minus the square root of b squared minus 4ac is all the numerator, and then that's all being divided by 2a. This will really test to make sure you understand your orders of operation. Okay? And then the last thing I would just say before we do some examples is when you have it in standard form and you're ready to plug stuff into the quadratic formula, make a list. A is this, B is this, and C is this. Okay, I'm going to do that. I'm going to demonstrate that for you in just a minute. And basically, once you do that, you're done with this equation. There's no more solving to do with the equation. You're plugging A, B, and C into the quadratic formula and then finding the solutions that way. Okay, so this one says x squared plus 2 is equal to negative 3x, and they want us to solve it using the quadratic formula. The first thing I would note is that it's not in standard form and it's not set equal to 0. So what I would do, what you should do on a problem like this, is add 3x to both sides so that you have x squared plus 3x plus 2 equals 0. This is what we want to use the quadratic formula for. And again, as I said, make a list. The a value is the number in front of x squared, and that is going to be understood to be 1. B is the 3, the c is positive 2. Okay, and again, once I have that, I'm going to be pulling these into the quadratic formula, and there is no other work or manipulation to do to the equation itself. We got what we needed out of that. Okay, so x equals negative b. That would be negative 3 plus or minus the square root of b squared minus 4 times a times c all over 2a, and a is 1. And this is the work that I should see on a quadratic formula problem. And there's probably going to be a few more steps as you simplify things, but this is kind of the big step to show me that you know what you're doing. Obviously, you're working from home anyway, but if you were here, And I was checking your homework. I was looking at your work. Well, I guess I am going to see your homework. So this is the work that I should see. And um, again, you're probably going to show more steps, but this is kind of the step that shows me you plugged things in the right place. Okay. So what does this simplify to? Now, if you're really good with your calculator and you're really good with orders of operation, could you type this whole thing in? Really good with parentheses too? Yes, you could. I'm not really all that confident with that myself, so I usually don't do that. And I'll simplify things a few times. 3 squared is 9. 4 times 1 times 2. Remember, orders of operation, we can multiply these before you're going to do the subtraction. That would be 8 all over 2 times 1, which is 2. That means that you really have negative 3 plus or minus the square root of 1. Square root of 1 is just 1 all over 2. And at some point you do need to break these up, and I think now is the appropriate time to break them up. Negative 3 minus 1 would be negative 4, divided by 2 would be negative 2. One of our solutions is negative 2. Negative 3 plus 1 would be negative 2, divided by 2 is negative 1. Negative 2 and negative 1 are our two solutions. Now again, I know, I'm a broken record, but I'm going to say it anyway. If you graphed y equals x squared plus 3x plus 2, it would cross the x-axis at negative 2 and negative 1. I know I keep bringing that up, but it's extremely important that you always link it back to the graph. In addition to that, looking at what the solutions are now, negative 2 and negative 1, this would have been factorable. We could have solved this a la section 10.4. And of course, anything that can be solved using the quadratic formula can also be solved using completing the square. Okay, but I am tasked with teaching you each one of these methods. So again, if you were taking my assessment, which you're not, I would tell you the method. You solve this one by using square roots, solve this one by graphing, solve this one by factoring, use the completing the square method for this one, and then what our current topic is the quadratic formula, and that's what you would do here. Also, they're not always factorable. We'll see an example, I think, next that's not factorable. So I think a quadratic formula / completing the square is kind of a last resort. If we didn't tell you which one to use, you could use whichever method you want, and I would kind of use that progression. Can I use square roots? No. Okay, try factoring. No. Well, then you'd have to resort to completing the square or the quadratic formula. Here we go. And they did check, by the way. I don't usually do that or show that, but here are the two solutions. They plugged them back in, and they both made the equation true. These are the only two solutions. All right, let's try that again. This one's already set equal to 0. That's standard form. So we have A is equal to 3, B is equal to 4, C is equal to negative 8. Okay, and then it's negative B, x equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. The critical line of work right there. And then simplifying, 16 negative, and then negative here is going to make this positive. 4 times 3 times 8 would be 96, I believe. All over 6, which then if I simplify a little further would be negative 4 plus or minus the square root of 112 all over 6. And a couple things that you could do from here. One thing you could do is, I'll tell you what I would do last. One thing you could do is type the whole thing in, okay? And if you're going to do that, you don't have a plus or minus button, obviously, so I mean type it in using plus and then type it in again using minus. If you're going to do that, you're going to need to put parentheses around your numerator, right? So it's open parenthesis, negative 4 plus the square root of 112, close parenthesis, divided by 6. And even then, some of your calculators are going to open a parenthesis with the square root, so you're going to need to close that one too, okay? And then do the same thing with minus. A second thing that you could do would be to take the square root of 112 and figure out what that number is. You might use the store feature on your calculator then, and then negative 4 plus that number after you've square rooted it, right? And then divide that number by 6, and then negative 4 minus the same thing. You could do it that way. I'm inclined to do it this way. Here's a third option, and this is what I do. I go -4 plus the square root of 112. In fact, I'm going to do that right now on my handheld calculator. -4 plus the square root of 112, and then I push enter, and I get a number. And then I simply go divided by 6. So I'm exercising the orders of operation there myself, and that is 1.097167541. It says round to the nearest hundredth, so that would be approximately 1.10. And then I'm going to do the same thing with minus. On my calculator, I'm going -4 minus the square root of 112, enter, divided by 6. And that's -2.43. And just to kind of close up what I had said earlier about problems that could be solved by factoring, this one is not factorable. Right? You wouldn't factor and get a solution that's 1.10. You don't factor and get massive decimals. Also, we didn't learn how to do this one using completing the square. That method does exist, but we didn't learn that in section 10.5. That's a topic for your Algebra 2 class. Okay, I think we got one more. A child throws a ball upward with an initial upward velocity of 15 feet per second from a height of 2 feet. If no one catches the ball, how long will it be in the air and round to the nearest hundredth of a second? Okay, now reminder that you have this, h equals -16 t squared plus the initial velocity is this number here, and they gave that to us of 15 t, and then plus the height, which they gave us again, initial height, which is 2. Do understand, I don't know if I did a really good job explaining this the first time I made a video on this. This term right here is the initial velocity upward, okay? And as you plug in small numbers for t, this is going to be the bigger number as it relates to this. However, as t gets bigger, and in this term it gets squared and then multiplied by -16, this becomes the bigger number. And I mean bigger irrespective of the sign. Okay, so because this one's negative, this one's positive, this one's negative. This is going to be a bigger negative number as t gets larger. Okay, so what happens? Well, this term starts to take over for this term. That's when you have the ball that gets thrown up in the air, it hits a peak, and then it comes back down. This is the gravity term. This is just the initial throw, and then the +2 again is a height. All right, now from there it would just be a quadratic formula problem again. They want to know where the time when the object that the child throws hits the floor, so that'd be at a height of 0. So really you're solving this, where A is -16, B is 15, and C is 2. Okay, so let's just roll to their answer here, save a little bit of time. Quadratic formula, there they are plugging all those pieces of information in for A, B, and C, solving. And they get two solutions, -0.12, +1.06. Do both of those solutions make sense? For the child throwing an object up into the air and wondering how long it takes for it to land situation? Obviously, only the positive answer makes sense. Here's what's going on, though. You do have a parabola. It opens down because -16 t squared, your a value is negative. It would look something like this. That's what the parabola would look like. And your -0.12 is this solution. Your +1.06 is this solution. And right here would be the initial height of 2. Now I haven't drawn it to scale, but these are the important points. Only this one makes sense to the answer, to be the answer to this question. So about 1.06 seconds. And I think that'll do it for this section. Thanks for tuning in.